So one of the things that is covered in 1.3 is composition of functions. So the main thing to remember is what you see here, that f of g of x is the same as taking the f function and plugging in g of x. So whatever is closest to the x, that function is going to be plugged into the outer function. So you got to work from the inside out. So please make sure you know that notation, because that notation is still found within a calculus class. So let's take a look at an example, and let's take a look at how we can find f of g of x and g of f. So if we want to find f of g of x, we're going to take the f function and we're going to plug in g of x. So I would work from the inside out. So I would even completely ignore that the f is sitting there, and I would ask myself, what is g of x? Well, that's equal to x squared. And that is going to become our input into the f function. So we know that we're going to take the f of x, where the original input was sitting, we're going to replace it with x squared. So we're going to get 4 minus 5 times the quantity of x squared. And then you can't do much to that, but you can, make it, simplify it where possible. There's not much you can do. But when the order changes, most of the time we are not guaranteed that f of g and g of f are the same thing. For many functions, that is true. They're not going to be the same. So here we're going to take inside of the g function, we're going to plug in f of x. So where the input is sitting in the g, we're going to replace that with the entire function. So I would suggest writing the entire function down, and then we can ignore that because now we know what is being inputted into our g function. And so we would get that we have to square that input. Now, most of the time for a quantity that's squared or cubed, you do want to actually square or cube that quantity. So remember, that means that you have 2 of those. And so you have to FOIL distribute, whatever. You get 16 minus 40x plus 25x squared. So hopefully you remember your rules of composition. That should be pretty straightforward. What I find is when you make it just an abstract model, you tend to do funky things. We're going to get to one of those, but let's practice just a few more. So now in example 7, this one is supposed to say the square root of x minus 4. The square root got disconnected on the old-fashioned app I was using when I created these. They didn't have a square root symbol at the time, so I had to try to make one. So. Now, you'll notice that they say f of g of x. So let's write f of g of h, f of g of h. Now, start yourself from the inside and work your way outward. So I am going to put h of x in its spot inside of the g. So that's where I'm going to put the x squared. Now I'm going to ignore that the f is there, and I'm going to input into the g my x squared. If I input into the g the x squared, I get 2x squared plus 1. And now I need to put the 2x squared plus 1 into the f function in its input. So I am going to get the square root of the quantity I'm inputting minus 4. And then simplify that as much as you can. You can't do much, but we can write that as 2x squared minus 3. Now you can't take the square root of the individual pieces, so you can't square root part of it without rooting all of it. If that was factorable and there was a perfect square that we could find and then remove, but otherwise that's as far as you can go with that problem. You are done unless you know somewhere what the x value is. Everybody good with f of g of h? And then we have here where I think they did this a little bit last year in ALEKS, where they were rewriting a function in terms of the inner pieces. So the way that I always think about it is what is stuck and what is on the outside. You want, if you're making f of g, you want g to be the inside function. You want f to be the outside function in its simplest form. So in this case, our outside function is tangent, so we write it as just tangent of x. Now, how could you check your work? Well, if I input g of x and it goes right here, it should look like big F. So that is how we can create a composition of functions that gives us the original function, okay? So usually I will make the g the inside stuff, and then the f the simplified version of the outside stuff. That thinking, that being able to reverse yourself will be helpful. Eventually, we are going to get to some complicated integration at the end of this year, and then that reverse thinking is going to be very helpful when we get to that particular application, okay? Any questions about example 8? Okay. But now let's use a graph, because I can see that sometimes you guys can overcomplicate things when you see a graph. So let's start with A. And it says to find f of g of 2. Now, g of 2 on the graph is what x value, or I'm sorry, what y value are we hitting when x is 2? Let's assume we hit nice spots, okay? My graph isn't great. Again, the application I used to make this is an older application from a long time ago, so my lines and things can be a little clunky. But let's assume it's that point right there. When an x value is 2, we hit the g function at a height of 1. So that is 1. Trying to keep it kind of color-coded for us so we can, for those of you that are visual, that sometimes helps. Okay, now we're done with the g function. We have used it. We're going to find where on the f function when an x value is 1 do we hit the y, or what's the y value when the x value is 1. So if you'll notice, if we are assuming that we hit at that perfect value, what is our height on the f function when x is 1? 4. So that is 4. So A, the final answer is 4. Now let's look at B. Now I'm going to rewrite that as g of f of 0. So the first thing, you're always going to start with the inside function. So we're going to go to the red f function. We're going to ask ourselves, what is the height when x is 0? So what's the answer there? 5. So that's 5. And then we're going to go to the g function, and we're going to say, what is the height on the g function when x is 5? Let's assume it hits there at 2, just to make our lives a little easier, okay? So that's that. For C, we're going to use the g function twice. It's g of -6. At 6, at -6, we're at a height of 2. So this becomes 2. And then we ask ourselves, if we use the g function again, if we are at x value of 2, we are at a height of 1. And then finally, we've got g of f of 4. If we have an x value of 4, on our f function, what is our height? 7. One, two, three, four, five, six, 7 is not in the domain of our g function, is it? It doesn't work. There's no values to pick. That happens occasionally. So in that case, just put an undefined symbol. Some of you are making your zeros look a lot like an undefined symbol. Here's the difference that you want to do that might help. Make your 0, you can do it with a, but that still looks like a theta. Don't make a line in your 0. I don't know. Just make sure that your 0 and your, or you make maybe like that. I don't know, but make a 0 and a undefined symbol more distinct. Some of you are not making them look much difference, and I don't want to, take off points if you meant one thing, but I don't, know that. Similar, that's why in mathematics, it's very common to put that slash through a Z, because if you make a 2 kind of quick, it will look like a Z. Same idea. Okay, just throwing that out there. Any questions on example 9? Okay, so then your assignment is in the section 1.3, wherever that is in the book. I would bookmark it because then you can come back to it very easily. And Notability and those things do allow you to bookmark. You're going to do the odds 1 to 5, 9 to 23, and 31 to 51. Your assignments, I believe, are due on Sunday, both 1-1 and 1-3. Okay, so you have the rest of class to work on any of those. Remember, you have the solutions. So showing me some work is always going to be essential. So then we both kind of can see that we put in the time to do it. So there you go.